Good evening and happy Monday. Final class meeting. So the results were to go over problems from previous exams. So that's what we're going to do. I have 3 previous exams. I think what we'll do is we'll just go through each one, right? So we'll do the first one, take a break, do the second one, take a break, do the third. Right? And if we get done early, then that's it. Otherwise, we'll just go as far as we can. All right, first up, we want to find all relative extrema of the function quantity 1 plus x squared raised to the 5th power plus 6x to the 6th. Because remember, what we want to do is we want to first determine the critical points. That is done by first taking the derivative. So our derivative, take a look at the first term. That is a general power, right? So that derivative, we bring down the power. Then power minus 1 times now the derivative of that function, which is 2x. Right, that one is simple. That's just 36 x to the 5th. When simplified, this will give us 10x times 1 plus x squared to the 4th power plus 36x to the 5th. So we want to go, is there anywhere where that is undefined? And the answer is no, it's defined everywhere, right? So set it equal to 0 and solve. So we are going to use technology. Solve command. Gets right. We just type in the derivative. Okay. 10x was 1 plus x squared. Okay, so the fourth one was what? Plus 36x raised to the fifth. Now it's better. Double equals, we want it to equal 0. And what are we solving it for? We're solving it for x. A lot of imaginary numbers. Okay, I know I can just do a domain. Okay, it's just comma. So I'm going to come back up here and I'm going to do another comma. So I can put in, I only want real solutions. We get a single 0. X equals 0. All right, so we could use the second derivative test. I think it's just easier. To use the first derivative test in this case. Take a negative value. We're going to plug it in up here. Negative 10 or negative 1. Let's do negative 1. That's easier. All right, 2 to the fourth. Negative 10 times 2 to the fourth. This will then be minus 36. So you have a negative plus a negative, stays negative. Do positive 1, right? This will be 10 times 2 to the fourth plus 36. You have positive plus positive, stays positive. First derivative test states if the derivative changes from positive to negative at a critical point, then that is a max. If it changes from negative to positive at that point, then it is a min. So we have no relative max. We have a relative min at 0, 1, right? But plug 0 back into F, you get 1. All right, next problem, they gave us a function, 7 times the quantity of root x minus root 2 all over x minus 2. We were asked to complete the table and use the results to guess the limit of f of x as x approaches 2. Right, and then this was the values. Right, so these are the values of x that we were given. They didn't actually give us a number of decimal places. So we'll just see what we get when we create the table. Yeah, okay. So first thing that I'm going to do is go ahead and define f of x times square root of x minus square root of 2 divided by no, not square root, just x minus 2. Now I'll do the table. Form table. Right, so what I want in the table is I want x and I want f of x. Using x as my table index. Right now I just have to put in the values. 1.6, 1.8, 1.9, 0.99, 1.999. 2.4, 2.2, 2.1, 2.01, 2.001. Now want table headings. Let's see if I can remember this. I think it is row and column. So I don't want any headings for the row. If I'm thinking this table's right, and then for the columns I want. Excellent, I got it. So I did remember it. And so what I'm going to do as the solution, right, for the table, instead of filling it out, I'm just going to copy and paste. Something's not right. Is it? Is that what I should have gotten? Yeah, I think what I have here is wrong. I think this is right. All right, so there's our table. There's our completed table. And we want to guess the limit. Well, it looks like it's going to be about 2.475. Right. If you look as we're approaching from the left, right, the values are decreasing. Right, and we're going towards 2.475, it looks like. As we come in from the right, the values are increasing. And again, right, 2.47456 is the final one. So it looks like they're just going up to 2.475. So right around 2.475 looks like what our limit would be. Right, next we were asked Evaluate this antiderivative, right? The antiderivative cosine of 6x. Okay, well, we have to let u be 6x, which would make du 6dx. Then look what we get. We're going to multiply by 1/6 on the outside. We'll multiply dx by 6. There's our u. 6dx, there's our du. Antiderivative cosine is sine. Replace u. We get as an antiderivative 1/6 sine of 6x plus c. Here we're asked, find the area of the region under the graph of x squared minus 2x plus 5 on the interval -1 to 2. Remember, area is an integral. Right, what we want to do is we want to integrate the function over that region. And what we should really do is make sure that this function is strictly positive. Need to do anything fancy. And it is, right? Strictly positive. Or strictly not negative, I should say. Right? Fundamental theorem of calculus. Remember, that says first, we want to find the simple antiderivative. First term, power rule. Add 1 to the exponent, divide by the same. All right, and then we're going to do the same thing, and then just 5 is 5x. Evaluated -1 to 2. That is 8 plus 1 is 9, divided by 3 is 3. Minus 4, minus 1 is 3. Plus, and will be 5 times 3. Oh, what's going on now? We got an area of 15. And specifically 15 square units. Right? Now we're asked to evaluate the given definite integral. First thing we need to do is simplify this. So you can write this as 2x minus 7, right, plus 2 times x inverse. And now this is a simple matter, isn't it? Simple antiderivative, x squared minus 7x. Plus 2 times log of the absolute value of x. But since we're on the interval 1 to 3, x is strictly positive, so we don't actually need those absolute value signs. Nine minus 1 minus 7 times 3 minus 1 plus 2 times the log of 3 minus 1. Two log 2 minus 6, 4 log 4 minus 6. All right, Newton's law of gravitation. Right, we did go over this, you should remember it. So we want to evaluate the rate of change of the force with respect to the radius when the radius is 8. First, find df dr. Right? Power rule will give us negative 2g big M little m all over r cubed. Can replace big G little, big G big M little m with gamma, just so I don't have to write it again. But it's just some constant, right? It's just some real number. Remember, big G is the universal gravitational constant, and then the two M's are the masses. And so when radius is 8, we get negative 2 gamma over 8 cubed. Well, remember, 8 is 2 cubed. And we get negative gamma over 2 to the 8th. And 2 to the 8th, 256. But remember, gamma is that value there. All right, next up, we want to find dimensions of a rectangle of area 324 square feet that has the smallest possible perimeter. Right, so let's label length width. And we know it has an area of 324 square feet. Right, we wish to minimize the quantity perimeter, which would be 2 length plus 2 times the width, right? Under the constraint, that area, which has to be length times width, is equal to 324. We can solve for either length or width, right? It does not matter. So we say the width is 324 divided by the length, which allows us to write the perimeter function strictly as a function of length. Right, where we know length is going to be positive. Now, if the width is 0, well, actually, it doesn't matter, right? The width is going to keep going, right? It's going to keep getting smaller and smaller and smaller. So theoretically, the length can be infinite. Right? You determine that by this function right here, don't you? Right, so let W go to 0. What does L have to go to? L has to go to infinity. Now we want P prime. Maybe 2 minus 648 over L squared. 2L squared minus 648 all over L squared. We already know it's not going to be undefined over our domain, which is 0 to infinity, open. So that is equal to 0, we have to have L squared minus 324 equal to 0. So L would have to be plus or minus root 324. Which is plus or minus 18. But since L can't be negative, we get a single critical point at 18. Let's find the second derivative. 1296 over L cubed. Evaluated 18 is going to be greater than 0. Means this is a min. Specifically, it's an absolute min. So we know what length, it's 18 feet. The width, I'll just plug it back in to the constraint. Be 324 divided by 18, which is 18. I'm gonna spell. So the dimensions that minimize the perimeter, 18 feet by 18 feet. All right, find the derivative of the function 4x minus 7 root x plus e to the x plus 2. Well, this should be simple. All right, really nothing fancy going on here. Derivative of 4x is just 4. Derivative of 7 root x, right? No, derivative of root x is 1 over 2 root x. Derivative of e is e to the is e to the exponent times the derivative of the exponent. Well, the derivative of x plus 2 is just 1. I'm going to do that. It's fine. And so right circular cones you typically think of, right? When you think of a cone, typically you're thinking of a right circular cone. Volume of a cone, right circular, pi over 3 r squared h. Right, so we're told that at a certain instant of time, the radius and height are 3 inches and 2 inches, and they're increasing at a rate of 0.3 inch per second and 0.2 inch per second, respectively. We want to determine how fast the volume is increasing at this instant, and we're told to keep our answer in terms of pi. I'll do it this way. Radius at this instant is 3 inches. The height, 2 inches. The RDT at T naught. All right, we want to find dVdt at this specific instant, right? And we're given, of course, radius at this instant is 3. It's increasing at 0.3. The height at this instant is 2, and it's increasing at 0.2. Derivative. Well, pi over 3 is a constant, scalar multiple. We're going to keep it and then multiply it by the derivative of r squared times h, which is a product. Right. Product rule. I'm going to take h times the derivative of r squared, which is 2r dr dt, plus r squared times the derivative of h, which is dh dt. dv dt then at the specific instant in time. Pi over 3 times 2 times 3 times 2 times 0.3 plus 3 squared times 0.2. Twelve times 0.3 is 3.6. 9 times 0.2, 1.8. Which is what, 5.4? $54 divided by 3. 18. And then the units would be cubic inches per second. 1.8 pi cubic inches per second. The altitude of a right triangle is increasing at a rate of 1 centimeter per minute. The area is increasing at a rate of 2 square centimeters per minute. We want to find the rate the base is changing when the altitude is 10 centimeters and the area is 100 square centimeters. Actually, I was just trying whatever. Doesn't matter. There's the base. There's the height. And obviously, that's area. Okay, so first, write out what we know. What do we know? We know the h dt is 1. We know that the a dt is 2. H is 10. A is 100. We want to find dB dt. Area is 1/2 base times height, which means base is twice the area divided by the height. Gonna need that. dAdt, 1/2 h times dB dt plus b times dH dt. This will be not yet. Let's do this. Height is what? 10? Base is 2 area over height. Area is 100. Height is 10. So that's what, 20? And then dH dt is 1. All right, dA dt is 2, right? Perfect. Two equals 5 dB dt plus 10. This means -8 equals dB/dt, which means that dB/dt is negative 8/5 centimeters per minute. Right, in other words, the base is decreasing at a rate of negative 8/5 centimeters per minute. Once we evaluate the limit as x approaches infinity, sine of 2x over 2x. All right, so as long as x is not 0, we would have that sine of 2x over x is between negative 1 over 2x and positive 1 over 2x. This limit, 0, right? Which is the same as that limit. They're both equal to 0, so that middle limit also has to be 0 by squeeze theorem. right? C of t is total value of US currency in circulation at a time t. Table's going to be given. That gives the values of this function from 1980 to 2000 in billions of dollars. We wish to estimate the value of C prime of 1990. So C prime is going to approximately be the rate of change of C over the interval 85 to 95. Right? Because remember, what is C prime? It is an instantaneous rate of change, right? And it's the limit of the average rate of change. We're going to get about $24.3 billion per year. Simple one again, just differentiate this function. This is just a simple scalar multiple power rule. So negative 4c times y to the minus 5. You want to find the interval in which the curve given by f of x equals the integral from 0 to x of dt over 7 plus 7t is convex, right? Or concave down. F prime of x by fundamental theorem part 1. Is 1 over 7 plus 7x. This makes the second derivative negative 7 over 7 plus 7x squared. This is always negative, which means it's convex everywhere. So the question is, what is our domain? It would be 0 to infinity. Right? Because the lower bound is 0. So we're going to write out the expression to evaluate this integral using right endpoints. We're not being asked to actually evaluate it. Limit as n goes to infinity. delta x pi over n times the summation pi equals 1 to n square root sine of pi over n times I, right? Because for right endpoints, it's the start of the interval, 0, plus delta xi. That would be the expression that we would have to evaluate. Okay. So what we'll do is go ahead and let's make it a 15-minute break. Let's take a 15-minute break. Come back at 7:50, and then we'll continue on. And we're back. Right, continuing on. We're going to evaluate this limit. And we're going to do so without the use of L'Hopital. All right, well, remember the first thing we do. Factor out the largest power from the denominator. Right, now we distribute that through to the numerator. They're going to go to 0. And so we're just left with -4/7. We're given x squared minus 1 over the absolute value of x minus 1. We're going to evaluate the limit of that as x approaches 1, or explain why it does not exist. Let's start from the left. For to the left, that would mean that x minus 1 is negative. You need to replace absolute value of x minus 1 with negative quantity of x minus 1. Okay. So we get a limit of negative 2. Right. Now we look at the right-handed limit. Well, from the right, x minus 1 is positive. So we can just drop the absolute values. We get positive 2. Therefore, the limit does not exist. And that's why the two one-sided limits are different. Evaluate this limit. Substitution, u gets us 0 over 0. And let's factor out an x from the numerator. Again, we're not using L'Hopital's rule here. Factor the denominator. So it'd be x minus 4 quantity squared. Left with a limit of x over x minus 4. We'll get 4 over 0. So this is either positive or negative infinity. Right? It's one or the other because it's a one-sided limit. And it's negative infinity. Because if you notice, the numerator is going to be positive, right? Because we're really close to 4. But the denominator will be negative. We want to find this derivative. Right? Y prime. So remember the derivative of the log function. The derivative of what we're taking the log of right, it's going to be a product rule. So second times derivative of the first plus the first times the derivative of the second. And then we divide by what we're taking the log of. And we need to fully simplify. Factor out next to the fourth and a sine cubed from the numerator. And that's what we'll be left with. We could actually go a bit further if we wanted to. We could actually write this as 5 plus 4x times the cotangent of x all over x. Right, which to me is a lot simpler. Find equation of the tangent line to the curve given by y equals sine of xy to the fifth at the point pi over 2 comma 1. So first we're going to want dy dx. And implicit differentiation, we're going to do dy or ddx on both sides. And so derivative sine, it's the derivative of what we're taking the sine of. In this case, it's a product rule, times the cosine of that function. Distribute through. Now what we want to do is isolate dy dx. Why did I write that as a 4? That should have been a 5. No, not 4, 5. Factor out that dy dx. And then divide. All right, there's our dy dx. We want to evaluate this. At the point pi over 2, 1. All right, 1 to the fifth, cosine of pi over 2, well, that's 0. Slope is 0. Y is going to equal, remember, it was 1, right? Y naught plus the derivative times x minus x naught. Since the derivative is 0, tangent line is just the line y equals 1. Everyone find the derivative of cosine of the natural log of 3x. Be the derivative of what we're taking the cosine of, negative derivative of what we're taking the cosine of. Right, and then that, of course, is the derivative of 3x divided by 3x. Then times the sine of what we were taking the cosine of. Right, that'll be negative sine of the natural log of 3x all over x. Determine intervals of concave and convex for this function, as well as list out inflection points if there are any. All right, the function 6x plus 2 minus sine of x. F prime 6 minus cosine. We're only considering the interval 0 to 3 pi. All right, F double prime, just positive sine of x. Okay, that is defined everywhere. So set it equal to 0 and solve. All right, so x be any multiple of pi. Let's say I1 is 0. No, it's not, because it's an open interval. I1 would be pi, and I2 would be 2 pi, right? Again, because 3 pi is not included either. we'll go 0 to pi. We'll go pi to 2 pi. And then we go 2 pi to 3 pi. Sine is positive from 0 to pi. It is negative from pi to 2 pi, and then positive again, 2 pi to 3 pi. And so a concave, 0 to pi, unioned with 2 pi to 3 pi. Convex, pi to 2 pi. We have 2 inflection points, one at pi. All right, so we have to go back up. Sine of pi is 0. So it's what? It's 6 pi plus 2. And we have another inflection point at 2 pi. Again, sine of 2 pi is 0, so it's going to be 12 pi plus 2. Two cars start moving from the same point. One travels south at 50 miles per hour. The other travels west at 20 miles per hour. At what rate is the distance between the cars increasing 2 hours later? And we want to round to the nearest hundredth. So let's say there is the point where the cars start. Let's say this is car A. This is car B. Call this X, call that Y. Call this distance between them, let's just call it L. Furthermore, let's define west and south as the positive directions. dx dt, 20 miles per hour. dy dt is 50 miles per hour. We want dl dt after 2 hours have passed. Okay, well, our relation will be x squared plus y squared equals L squared. This means that L dot of 2 would be x of 2 times x dot of 2 plus y of 2 times y dot of 2. Remember that dot notation just means derivative with respect to time. X dot, y dot are constants. Twenty times x of 2 plus 50 times y of 2. We need to determine x of 2 and y of 2. Well, they're simple. they start moving from the same point. So right here, they both have 0 velocity. So wouldn't x of 2 be 20 times t, which would be 20 times 2? And then y of 2 would be 50t, or 50 times 2. $800 plus $2,500, 5,000. So after 2 hours, the distance between the two cars would be increasing at 5,800 miles per hour. Want to use Newton's method. Means we're going to come over here. Our function is arc cosine of x minus 3x. Oh, we need to determine Let's just look -5 to 5. Okay, so let's change that. -2 to 2. That should give us a pretty good estimate. Looks like 0.4 be our first guess. I have to go for over 10. Set n to be 0. 0, yes. And we'll set error at 1. So as long as error is greater than 10 to the -5, xn plus 1 will be x of n minus f of x of n divided by f prime of x of n set our new error, absolute value, x of n plus 1 minus x of n, and then n plus plus. Right, and then all we want is xn minus 1 to 5 decimal places. Root is approximately 0.39005. Oh, here's what I'll do. I'll just do it this way. So wind shift S. So actually two things here. I'm going to need you. Are you kidding me? Go, problem solved. All right, we're also going to need this bit up here. And that would be sufficient for the work. Particle moving with velocity. V of t equals sine t minus cosine of t. We wish to find an expression for the position at any time t if the particle has an initial position of 3. Well, remember, that velocity is the derivative of position. Which means position will be the antiderivative of velocity. That gives us negative cosine of t minus sine of t plus an arbitrary constant. We need to solve that. Well, we do that by noting that s of 0 has to be 3. Cosine of 0 is -1. Sine of 0 is 0. All right, so 3 has to be -1 plus c, meaning c is 4. So that would be our position function. 4 minus the quantity of cosine of t plus sine of t. Evaluate the same antiderivative. Cosine the 6th x times sine of x. Well, this is clearly u sub, right? U is cosine, du would be negative sine. This is u to the 6th. There's your du. That antiderivative, negative u to the 7th over 7 plus c. Replace u with cosine, and we get c minus cosine to the 7th x over 7. We should evaluate this integral. Negative 7 to 7 of root 49 minus x squared. It's better. This is the graph for y equals the square root of 49 minus x squared. Notice it is a semicircle. Which means it's going to be a half of the area of the full circle. So that integral is 49 pi over 2. And so it had been brought to my attention that while there was an assignment 24 on My Open Math, there was none posted on Teams. So I did post it, and I extended the due date to tonight. So assignment 24 is due tonight, along with the replies for the shape of the graph discussion. Final reflection will be due tomorrow night. And then the final exam. Final exam will go up on the 16th at midnight. It will be due the 17th at the end of the day. Final grades are due on the 21st, and they will be available in self-service on the 22nd. However, once I grade your final, right, you will see the final grade in the comment. I should have final exams graded by Friday. So you should be able to see your grade by Saturday. Again, not in self-service, right? You have to go on to open up the form and see the comment. Right. I don't know how the posting works. Like, I don't know if I submit grades to self-service on Friday, if they're post Saturday, or if they just wait until the 22nd to post everything. I think that they wait till the 22nd. I think that's how it works. So no matter how early I post them or I submit them, it doesn't post until the 22nd on self-service. I think that's how that works. That felt like a very long 5 weeks. Right. It was tough, a lot of material in a condensed amount of time, but you managed to get through it. So congratulations. I will most likely not be available Wednesday and Thursday night. Right. So last semester, I made myself available on Teams. Those last 2 nights, I probably will not be able to do that this term. You can still message me on Teams, and I'll answer it. So if you have a question, like clarifying something on the final, if you message me on Teams, I should still see it and reply. I just won't be available at night. Heads up, tomorrow I will not be home, so I may not respond to any messages tomorrow. All right, that's it. Everyone, have a wonderful rest of your night. Have a wonderful rest of your summer. I think we're, 3 weeks until the start of the fall term? Something like that? Or is it 2 weeks? No, 3 weeks and a day. So we have 3 weeks and a day left of summer until the fall term starts. So enjoy the rest of it. Hopefully you don't see me again next term, because that would mean that you're retaking Calc 1, right, or pre-calculus. And we don't want to do that, right? So no offense, but hopefully you don't see me again. Have a good evening.
Thank you.
Thank you.